Thanks, Hexa-X, for this invitation for this workshop. I think today I'd like to give your talk on the 6G mobile network, which will evolve from the communication as a service to X as a service. First, I think I like to talk about the driving forces for 6G mobile network because I was always be asked why your company has launched the world largest 5G network. You are so eager to drive the study on 6G. I think the driving forces comes three parts. The first one, of course, is the learning, the lessons, and also the experience from 5G practice. According to our almost 5 years practice on the 5G network, we do see to explore the differentiated service use cases. We have tried our best to monetize the network's capability, but unfortunately, we do see the only traditional connection is not enough. The AI, cloud computing, etc., is also demanded from our customer, especially from vertical players. What we have done, we try to introduce these capabilities to the network in different way, but it doesn't work well in current architecture. I think what we have learned from 5G. Another thing is the poor business adaptability, because especially for 5G, we do believe the vertical applications is our future for the whole mobile community. But from the practice, we do see just I have mentioned before, the vertical applications not just demand the communication, but also the computing, AI positioning, etc. is also needed. What we have done, we try to introduce such kind of new capabilities by simply overlays of the new capabilities on the current 5G network. It needs to very low resource and also cost efficiency. And also typically our customers always complain to us why your solution is more expensive than Wi-Fi. And also for the current 5G network architecture design is not so flexible and cost-friendly, especially for the differentiated use cases. It needs quite a long time for the dedicated development and also the high cost and also difficult to fulfill the customized and personalized demands. So I think this is why currently most of the operators are complaining about the monetization of these 5G networks, especially on the network deployment, the power consumption, and also the cost for the maintain and operation of the whole networks. The second driving force is the requirements from the new service applications and also, of course, the scenarios. Whenever we talk about the 6G framework of the ITUR, Work Party 5D, and also the different reports from different projects, we do see there's two aspects of the KPIs should be improved for 6G. The first one, of course, is the traditional communication KPIs to be improved, like the experience data rate, spectrum, and power efficiency, latency, and also connection density should be further improved, especially compared to 5G. And also, on the other hand, we need more dimensional capabilities, like we have learned from 5G. Besides the communication, the sensing, computing, and the AI, and also the big data, also required for the individual use cases in different aspects, and also to expand the coverage of the network to provide the solutions for the new use cases like the unmanned drone, like the airplane, etc. Integration of the terrestrial network and the non-terrestrial network is also very important. The third driving force is the technology trends. Due to the convergence of the data technology, operation technology, and IT technology and CT technology, we do believe its convergence will becomes deeper and deeper in the next few years. So it provides us an opportunity to natively integrate the communication, sensing, computing, big data, and etc. in a native way. I think especially due to recently this very fast progress on the cloud computing, AI, and also the big data, is really shine a line like what we expected to really address the very differentiated use cases and the personalized customer demand from our customers. Based on all this consideration, we need to consider how we, based on the technology progress on the different aspects, how can we just design a more proper 6G network to really address the differentiated use cases requirements from our consumer customers and also the vertical customers. So for 6G, based on what we have mentioned before, we do believe 6G will evolve from a mobile network to a mobile information network. That means it will not just play a role in the transmission, but also play an important role in each steps of the information service providing, like the data collection, the storage, data transmission, data processing, and also data information application. So based on this vision, we do believe for 6G network design, it should have four goals. The first one is the global coverage. I think many of us has mentioned it a lot. I don't like to emphasize it in more details. And the second one is the immersive performance. It's very important for us to upgrade especially the consumers' user experience based on the 5G, what 5G have done, and especially to how to connect the people to the metaverse, etc. I think it's very important to improve the network's capability, not just on the data rate, but also on the latency, etc. To really provide the immersive user experience to our customer will be very, very important. The third one is the integrated capability, just like I have mentioned before. For the traditional 5G use cases and also for the potential 6G use cases, we do see only the communication is not enough. We need more. So the 6G network should be beyond the communication. The sensing, computing, AI security, big data should also be integrated in a native way in the 6G network. And the last one I think is very important is also the lessons from 5G. For 6G mobile network, it should be a platform for the operators to patch different capabilities together and provide the customized and personalized service to our customer is the best way for us for the mobile operator to monetize this network capability. So how to integrate the different capabilities and how to provide the service in an on-demand way and plug and play way, and also open to all the customers is very important. So the platformized network will be one of the goals for 6G mobile network design. So based on the consideration and discussion above, we do believe for the 6G network design, there's 6 principles need to be considered at the beginning of the network design. The first one is the on-demand fulfillment network. That means we should make sure the service providing can be customized and personalized in an on-demand way. The second principle is the light network, because it's a heavy burden for the mobile operator for the large-scale network operation and maintenance, especially for our current 4G and 5G, etc. So for 6G, we definitely need to consider how to simplify the network and provide a light network. Not just only the plug-play deployment, but also how to simplify the network orchestration, how to simplify the network's operation and maintenance, and also the functions configuration, etc. The third one, of course, is the soft networks. That means based on the DOICT convergence, we do believe it's a time for us to consider a fully software-defined network. That means not just the core network, but also the radio access network, and also the device could be designed in a software-defined way, and also the capability exposure should be also supported native way. The fourth one is the native AI. That means for 6G mobile network, we should support the ubiquitous AI application. That means anywhere, any place. So for the mobile network, of course, we need to consider how can we support such kind of use cases in a high efficient way. The most important thing is how can we just provide the necessary acceleration model, computing power, and the data, and also the communication capabilities required by the individual use cases. I think that's the idea of the native AI. How can we just provide all the elements required by the AI application in an on-demand way, but not just in a patched or added-on way, That's the meaning of the native AI, and also provide AI as a service to not just the internal application, but also the external application of the network. The fifth one, of course, is the native security. That means how can we just design the security mechanism just like the ML system of the system. It cannot be decoupled from the network. Anywhere you can be guaranteed with the corresponding security requirements. The last principle is network's digital twin. Based on the network's digital twin, of course, we can provide the mobile operator zero-touch maintenance, and thus reduce the cost and reduce the manual interruption to the network, and provide the operation and maintenance in advance, and thus can guarantee this network's resilience and also reliability and continuity, etc., and also can provide the self-evolving of the network's introduction and also the new feature, new version, etc. So based on all the goals and the design principles of the 6G mobile networks, how it really looks like. First, I think from the deploy architecture perspective, we can see here for future, of course, we will have a terrestrial network. We will have a non-terrestrial network like the NEO, GEO, and also have STRONGs, etc. And also the core network will be deployed in a distributed and autonomous way. That means for the core network, its functions can be either to be integrated with different use cases for the different and also even with the edge devices itself. From the terrestrial network itself, you can see the different bands can be coordinated together to provide the nationwide coverage. And also based on such kind of deployment architecture, satellite network will play a very important supplementary role and extension of the terrestrial network, and also the seamless user experience between satellite and the terrestrial network can be guaranteed, and also the flexible network deployment can be provided to achieve minimalist of the network deployment cost. And also by such architecture, a reliable network can be guaranteed when the terror or even the disaster really happened to the world. From the logic architecture perspective, you can see the network itself can be split in 3 layers. The bottom layer is the physical infrastructure layer, including the traditional tower for the antenna, for the AAU, for the RU, etc. And also all these elements are connected to the IDC. And the different IDC is also connected by the fiber network. Above it is the logical function layer. That means the 6G mobile networks network functions are deployed in the IDC in an on-demand way, and based on the management orchestration, and also based on the demands from the different use cases and also different scenarios, the corresponding service and functions, and also the physical layers resources can be orchestrated and integrated together to set up the server and the instance for the networks service providing, and to set up the individual capabilities, or even the collection of the combination of different capabilities, like I've mentioned here, and together to serve for the individual use cases in an on-demand way. By this way, the network can be regarded as a platform, and different capabilities can be patched together to serve for the individual use cases in an on-demand and customized and personalized way. By this way, we can enable everybody to develop their own services, and the network can support such kind of service launch in the network. Logical function design perspective to support the XaaS services. We need the extension to the traditional 5G network logic function design. For the current 5G network, it focuses on the communication service providing, so we can term its logic function design as a communication plan. In practice, of course, it can be composed as a control plan and user plan. To further support the new services like the data as a service, like the computing as a service, and the AI as a service, and also security as a service, the different extra plans are proposed to introduce to the network. For example, here the data plan is introduced to provide the data service to our customer and guarantee its service quality. And also the computing plan is introduced to provide computing service and AI, and also plans introduced to support the AI as a service, etc. And also based on all these new plans, management and orchestration plan is also necessary to provide the end-to-end resource and function orchestration and management. And specifically for the traditional communication plan design, of course, we will have, 60 will inherit the core concept of the service-based architecture from 5G, and also extended it to cover not just the control plane, but also the user plane, and also the radio access network, and also even the terminal itself. We termed it as a holistic service-based architecture. Based on this, we can provide software-defined network in an end-to-end way. That means based on the user's demand, we can dynamically orchestrate and integrate different functions, different services, and or different corresponding physical resources together to set up the service providing instance to serve for the different use cases. This way, we can improve the adaptability of the network to the differentiated use cases greatly. For data plan, I think, of course, we should consider how to support the data storage management, data collection, and processing and analysis, and of course, the service orchestration for the data. Just give you an example. And also, similar design has been considered for the computing plan. How can the computing task be executed, and how the task is orchestrated, and how the computing resource is managed, etc. And also for the AI plan design specifically, we need to consider several changes. The first one is how to design a unified network AI framework to support the ubiquitous intelligence, and also how to support the native design and provide the model acquisition computing resource, computing power and data, and also even the communication capabilities in an on-demand way, and also how to provide the full life cycles quality of service management. Based on this, we have a design example, just show you here. And also for the security plan, I think similar principles has been considered. How there's several changes that need to be considered. I just put it here, and also the security decision making and the control, and also the capabilities. Three type of the functions or capabilities need to be designed to support the corresponding change compared to the traditional security mechanism design. And similar, I think the management and orchestration plan design also show you here. I think they are split in three parts: the capability exposure, operation and maintenance management, and also the cross-domain data management. And also it have fully considered the network digital twins design to fully support the zero-touch network operation and maintenance. And finally, I just give you a brief introduction. In China, and China Mobile also work together with our partners, try to build up an experiment platform to validate the what we have mentioned before, try to support the native integration of the communication, sensing, computing, AI, etc. Try to make the network as a platform to serve the individual, the differentiated use cases. And also here is just a copy of our what we have done for the radio parts by now, and further, as more and more capabilities will be integrated in this platform, then we can just really to validate what we have, the concept of our design. That's all my presentation. Thank you.